Let's imagine you've asked your team to go into this mural and post sticky notes with their ideas for things that the team should stop doing, things the team should continue doing, and things the team should start to do. You can see some pretty good ideas listed here. Someone says, we should keep meeting minutes, loving the on-site daycare, stop forcing everyone to attend the all hands in person. These are all pretty good. So as the leader of this team, you might go into the mural and make some boxes and label them stop, continue, and start. And if you really had just this many sticky notes, you could probably drag them in by hand, and that wouldn't be too bad. But if you had a really big team and you had 100 sticky notes, that would be very tedious. So let's use a large language model to classify these sticky notes, and then use the Mural API to move them into the appropriate box. There's two ways you could go about doing that. The first way would be to manually describe each of the three classes. So let's do that now. In the stop box, the description says things people want to stop doing. In the continue box, it says things people like, so we'll continue to do them. And in the start box, it says things people think we should start doing. Now in my notebook, I can read those descriptions using the Mural API, and I can tell what box they're in based on their XY position. So here you can see a structure showing that the description for the stop category is things people want to stop doing, the description for the continue category is things people like, and so on. Here's an example of a prompt that you could use to get a large language model to classify each of the sticky notes. The prompt says classify the message into one of three classes, stop, continue, start. The three classes are, and then there's the descriptions. Then you can see a little placeholder, a %s. That's where each individual sticky note text will get substituted, and that's what we would send the large language model to do the classification task. So if we do that on a loop, you can see the results here. This is pretty good. You can see the stickies that were classified as stop, continue, and start. Now let's use the Mural API to move the stickies into the correct box by matching the box label with the classification for that sticky. Not bad. Let's reset things and look at how you could do this task in another way. Instead of describing the three classes, you could choose a few example stickies that represent the class. Okay, let's see. Here's somebody who's not a fan of the daily stand-ups. Here's someone who doesn't like the all-hands meetings. Here's someone who thinks we should continue the on-site daycare. Here's a good idea. Start recording the meetings. Here's someone who likes the fact they've got a meetings-free afternoon. And somebody thinks that we should start keeping meeting minutes. So each class now has two examples of stickies that belong in there. Back in the notebook, you can see we can read those exemplars, and we can tell which box they're in based on their XY position. Here's an example of a few-shot prompt we could send to a large language model to classify sticky notes. You can see that we've pulled in the labels of the boxes as the class names, and we've pulled in the text of the exemplar sticky notes in the few-shot examples. And again, there's a little %s as a placeholder, which is where the new sticky note text will go that we want to classify. There you can see the remaining sticky notes have been classified. Now, back in the mural, let's use the API again to move the classified sticky notes into the appropriate box. These examples demonstrate how useful large language models can be. We were able to prompt a large language model out of the box using quite simple prompts without even needing fine-tuning.